Hello students of class 9, advanced students. I'm going to, I have already started exercise 6.3. I have done up to question number 15. Now I am going, in this video, I am going to start from question number 16. In a GP, the sum of n, 2n, and 3n terms are respectively S1, S2, S3. Prove that S1, S2 minus S1 and S3 are in GP. So, see, N, Sn, this is represented as S1 and this is equal to N by 2. This is the sum, sorry. Sn, this is equal to S1. So, this is equal to A, 1 minus r to the power of n by 1 minus r. This is equation 1. Now S2n, which is represented as S2, this is equal to A, 1 minus r to the power of 2n by 1 minus r. This is equation 2. And now S3n, this is S3, this is equal to A, 1 minus r to the power of 3n by 1 minus r. This is equation 3. Now here we have to prove that S1, S2 minus S1 and S3 minus S2 are in GP. So here you see that first of all, S2 minus S1, S2 minus S1, A, 1 minus r to the power of 2n, 1 minus r, minus A, 1 minus r to the power of n, 1 minus r. Now here I can take a common A, 1 minus r, I can take the common here. So 1 minus r to the power of 2n minus 1 plus r to the power of n. So 1 minus 1, it cancels out, and A by 1 minus r. So here r to the power of n minus r to the power of 2n. So now again A, 1 minus r, this is r to the power of n, and here I can write it like this. 2n means r to the power of n plus n. I can write like this. 2n means n plus n. So this A, 1 minus r to the power of n, I can write this applying the indices law, r to the power of n into r to the power of n, same base. So the power gets add up, n plus n, this is 2n. So by the help of this, I can take r to the power of n common. A r to the power of n by 1 minus r, this comes out to be 1 minus r to the power of n. This S2 minus S1. So I'm leaving here S2 minus S1. I'm leaving here this. Now I have to find S3 minus S2. Now I have to find S3 minus S2. S3 minus S2. This is A, 1 minus r to the power of 3n by 1 minus r minus A, r to the power of 2n, 1 minus r. Now again I can take common r, A by 1 minus r, 1 minus r to the power of 3n minus 1 plus r to the power of 2n. So now plus 1 minus n cancels out, 1 minus r, so r to the power of 2n minus r to the power of 3n. Now I can write A by 1 minus r, I can write this as r to the power of n into r to the power of 2n, and here I can write this as r to the power of one minute. A 1 minus r, I can write this as r to the power of n plus n, and here I can write this as r to the power of 2n plus n. It is better, I have to keep it like this only. 1 minus r, I have to keep it like r to the power of 2n minus r to the power of 2n into r to the power of n. So here a 1 minus r to the power of 2n is common, 1 minus r to the power of n, it is left. This is S3 minus S2. This is S3 minus S2. Now we have to show that, this S1, S2 minus 1 and S3 minus S2 are in GP. This we have to show. Therefore, I'm going to do S2 minus S1 by S1 and S3 minus S2 by S2 minus S1. So left hand side is S2 minus S1 by S1. So S2 minus S1, this is here I have already done for you. AR to the power of n, 1 minus r to the power of n by 1 minus r divided by S1. S1 is this a 1 minus r to the power of n by 1 minus r. So what happens here? In this a r to the power of n, 1 minus r to the power of n by 1 minus r into 1 minus r, a 1 minus r to the power of n. You see this cancels out, this cancels out, a cancels out, only r to the power of n remains. Now I am going to do the other part. The other part is this S3 minus S2 divided by S2 minus S1. So S3 minus S2, is this one, that is a r to the power of 2n, 1 minus r to the power of n by 1 minus r divided by, now S2 minus S1 is this. This is a r to the power of n, 1 minus r to the power of n, 1 minus r, 1 minus r. Now a r to the power of 2n, 1 minus r to the power of n, 1 minus r into 1 minus r by a r to the power of n, 1 minus r to the power of n. Here you see this cancels out, this cancels out, remains is 2 r to the power of n, r to the power of n. Applying indices rule, it becomes r to the power of 2n minus n, so r to the power of n. Now what do we have find? We have find that this is this is right hand side. So we find that this left hand side is equal to right hand side. So left hand side is equal to right hand side. Therefore we can say that S1, S2 minus S1 and S3 minus S2 are in GP. This we can say. This is proved. Now again I am going to question number 18. Question number 18. This is divide 63 in 3 parts in such a way they form a GP and the product of the first two is equal to 3 by 4 times the third part. That means divide 63 into 3 parts, they are in AP. So let us take A, AR and AR square. We have divided 64 into 3 parts and that means this. So I can write here A plus AR square is equal to 63. This is equation 1, and in the second case it is given the GP and the product of the first two parts. Product of the first two part is 3 times the third part. Means A into AR, that is equal to 3 by 4 third part AR square. This is equation 2. Now let me do one thing here. From equation 2, that is A square R is equal to 3 by 4 AR square. Here see this A cancels out, this R1 cancels out. A is equal to 3R by 4. So we get a relation A is equal to 3R by 4. Now I am going to put the value of this in equation 1. I am going to put the value, putting the value of A is equal to 3R by 4 in equation 1. So a plus ar plus ar square is equal to 64. Now a common, 1 plus r square is equal to 64. So 63, this is 63, sorry, this is 63. Now value of a is 3r by 4, 1 plus r square is equal to 63. So here 3r, 1 plus r square is equal to 63 into 4. This will be implies that this is 3r plus 3r square plus 3r cube is equal to, instead of this, let me do like this. R 1 plus r square is equal to 63 into 4 divided by 3. 3 2s are 1. So here this is r plus r square plus r cube is equal to 4 1s are 4, 4 2s are 8, 84. So r cube plus r square plus r minus 84 is equal to 0. Now we have to find the value of r. We have to find the value of r. So 4 cube, 1 with 4 cube, it comes to be 4. A rule which you have learned in polynomial. I'm going to take the help of this px method, pr, that is equal to r cube plus r square plus r minus 84. Therefore p value r value 4, that is 4 cube plus 4 square plus 4 minus 84. This is equal to 64 plus 16 plus 4 minus 84. This comes out to be 84 minus 84. This is equal to 0. So r minus 4 is a factor of r cube plus r square plus r minus 84. Now I'm going to divide it. When I divide it, now I'm going to divide it, that is r cube plus r square plus r minus 84 divided by r minus 2. R square, that is r cube minus 2r square minus plus cancels out 3r square plus r minus 84 plus 3r, that is 3r square minus 6r. So minus plus, this cancels out 7r. Why there is a mistake here? 84. What is the mistake here? This is 4. Sorry. 4 divided by r cube plus r square plus r minus 84. So r square, this will be equal to r cube minus 4r square minus plus, this cancels out 5r square plus r minus 84. So plus 5r, that is 5r square minus 4 5s are 20r. So minus plus, this cancels out 21r minus 84. So plus 21, this comes out to be 21r minus 84 minus plus. So r minus 4 into r square plus 5r plus 21 is equal to 0. That means I am writing it again here. Here your r cube plus r square plus r minus 84 equal to 0. So when I factorize it, r minus 4, r square plus 5r plus 21 is equal to 0. Now our value of r will be 4, because here we can't split this into middle term. 21 7 3s are 7 minus, so it will not possible to do this. So our value of r will be 4. Now since I have got the value of r, from this I will find the value of A. So A is equal to 3R by 4, that is 3 into 4 by 4, that is equal to 3. Now I have got the value of A. Value of A is 3 and R is 4. Now the terms are AR square. So 3 into 4, 3 into 4 square, 3, 12, 16 3s are 16, 16 into 3, it comes out to 48. So this is your answer. Let me check the answer. Exercise 6.3, exercise 6.3, question number exercise 6.3 is not given in this book. Say that it is not given in this book. Let me check 1 minute. Exercise 6.3, your question number 18. 18C, exercise 6. This is exercise 6.3. Question number 18, it is not given. 13, then 19. It is not given in this book. But to verify it, we can verify it. Divide 63 into 3 parts. That means you see 48 plus 12 plus 3. It comes to be 63. You add it up. 48 plus 12 plus 3. It comes to be 63. So you can check it yourself. So this is your answer. Now I am going to question number 19. Question number 19, here you see the terms A, B, C are between 2 and 18. 2AB form AP and BC 18 form a GP. If A plus B plus C is 25, then find the value of A, B and C. So here 2A and B are in AP. So A minus 2 is equal to B minus A. So twice A is equal to B plus 2. This is our equation 1. And next, B, C and 18 are in GP. So C by B is equal to 18 by C. C square is equal to 18B. So 18B, this is equation 2. And it has been given that A plus B plus C is equal to 25. So what I'm going to do is that I have to make some arrangement. That is here this is C. So see A plus B plus C is equal to 25. So what I'm going to do here, see in B, in place of B, this is C square by 18. I have placed C square by 18. And now here in place of A in place of A, that is B plus 2 by 2. B plus 2 by 2. Now B by 2 plus 2 by 2 plus C square by 18 plus C is equal to 25. This is 1. It has been shifted to here. So it becomes 24. And value of B again, it is C square by 18. C square by 18. This I have placed here. So now this will be C square by 36 plus C square by 18 plus C is equal to 24. Now here again your LCM will be 36. Your LCM will be 36. 36 will be the LCM. C square plus 2C square, because you see here 18 2s are 36. So 2C square plus 36C is equal to 24. Now this will be 3, which implies that 3C square plus 36C, this will be 24 into 36. Now here you take 3 common, so C square plus 3 1 is 3, 3 to the C is equal to 24 into 36. Now again c square plus 12c, that is 324 into 36 divided by 3, 3 8 is 24. So c square plus 12c, which comes out, this is 288. Let me check it. It is 288. 36 into 8, it is 288. So c square plus 12c minus 288, this is equal to 0, splitting the middle term. So c square plus this will be 24c minus 12c minus 288 is equal to 0, because 24 into 12, it is 288. Now c common, c plus c common, c plus 24 minus 12 common, c plus 24 equal to 0. This is c minus 12, c plus 24 equal to 0. So this will be c equal to 12. C can never be negative quantity. It will be positive quantity, because the value of this ABC is between 2 and 18, because it is given that the value of ABC is between 2 and 18, so C can never be negative, so C will be positive 12. Now I found out the value of C. I am going to find out the value of B. So C square is equal to 18B. C means 12 square is equal to 18B. 12 into 12 divided by 18, that is equal to B. So let me divide it. 12 into 12, that is 144, divided by 8. This comes out to be 8. 8 is equal to B. Therefore, 8 is equal to B. And last, I have to find out the value of A. I will take the help of equation 1. From equation 1, equation 1, 2A is equal to B plus 2. So 2A is equal to B, 8 plus 2. So 2A is equal to 10, implies that. Therefore, A will be equal to 5. Now your answer is, it becomes A is equal to 5, B is equal to 8, and C is equal to 12. Let me check the answer. Exercise 6.3. Let me check the answer. 6.3. 6.3. Question number 19. See 5, 8, and 12. Here 5, 8, and 12. Now I'm going to this question number 21. 21. So that in a GP the product of the two Rth terms, one from the beginning and other from the end, is equal to the product of the first and the last term. Let me write the format of GP, standard format of GP. AR square, AR cube, dot, AR to the power of n minus 1. So here it is asking us, so that in a GP the product of two Rth term, one from the beginning and other from the end. So Rth term from beginning, Rth term from beginning, it will be Rth term AR, that is equal to AR R minus 1. This will be from beginning. And Rth term from end, here this will be A. So AR, that is from end. Let me write this like A dash R. This is from end, represent as A dash R. Your A will be AR n minus 1. This will be A. And from the end, your common ratio will become 1 by R. 1 by R to the power of Rth term R minus 1. This common ratio will become this. So now by question, product of two Rth terms means AR into A dash R This is AR to the power of R minus 1 into AR n minus 1, 1 by R to the power of R minus 1. So this will be equal to A square R to the power of R minus 1 into R n minus 1 into 1 by R to the power of R minus 1. This and this cancels out. Therefore, this is equal to A square R to the power of n minus 1. And product is equal to the product of the first and the last term. Now, the product of first and last term. Product of first and last term. This is A and this. So A into AR to the power of n minus 1. This comes out to be A square R to the power of n minus 1. So now you can see that these two are equal. These two are equal. So therefore AR into A dash R, this is equal to A into AR to the power of n minus 1. Proved. Now I am going to question number 22. Question number 22. Question number 22, it is here 22. A, B, C are in GP. It is given that A, B, C are in GP. It is given to you. And if X is the arithmetic mean of A and B, means X is equal to A plus B by 2, and Y is the geometric mean of, and Y is the arithmetic mean of B and C. Y is equal to B plus C by 2. This is given to you, that A, B, C are GP. X is the arithmetic mean of A and B, and Y is the arithmetic mean of B and C. We have to prove that. We have to prove that first A by X plus C by Y is equal to 2. So let us take, now they are in GP. Since A, B, C are in GP, so I can write B by A is equal to C by B. So this is B square is equal to B is equal to AC. I can write like this. Now left hand side A by X plus C by Y. What is X? This is A by A plus B by 2 plus C by, what is Y? This is this, B plus C by 2. Now I can write 2A by A plus B plus 2C B plus C. Now your LCM becomes A plus B into B plus C. So here 2A B plus C plus 2C A plus B. Now this becomes like this. Your 2AB plus 2AC plus 2AC plus 2BC, and here this is AB plus AC, again B square and BC. Now this comes out to be like this. This is equal to 2AB plus 4AC plus 2BC, and below this is AB plus AC plus B square plus BC. Now I am going to do one thing, that is what I am going to say. This here 2 is common, so AB plus 2AC plus BC by AB plus AC. Instead of B square, I will write B square is equal to AC plus BC. So 2AB plus 2AC plus BC by AB plus 2AC plus BC. This 2 cancels out and it is 2, which is right hand side. It is proved. Now your second part proof is, that is, this is question number 22 I have written here. Your second part is this 1 by X plus 1 by Y is equal to 2 by B. Left hand side 1 by x plus 1 by y. Your value, this is 1 by x, this is from here, x is equal to a plus b by 2. So 1 by x will be equal to 2 by a plus b, and y is equal to b plus c by 2. Therefore 1 by y will be equal to 2 by b plus c. Now your LCM is a plus b, b plus c, 2 b plus c plus 2 a plus b. So here 2 b plus 2c plus 2a plus 2b. Now this below ab plus ac, b square plus bc. So this comes out to be this is, so see 4a 4b, 2a plus 2c plus 4b by, that is ab plus ac. I can write the value of one thing I'm going, instead of BC, instead of AC, let me write B square. See here it is given B square is equal to AC. So instead of AC, I have written B square plus B square plus BC. So here above, a numerator will be 2 common, A plus C plus 2B, and in the denominator you can see that you can see B is common, B is common. So this will be A plus 2B plus C. This and this cancels out, and this equal to 2 by B equal to right hand side proved. Now the last question I'm going to do for you, this is question number 23, the last question I'm going to do for you. Question number 23. Here, if the pth and the qth and the Ra term of an AP are in GP, then so that their common ratio is this. That means AP of an AP. So this will be A plus P minus 1 into D. Now AQ, this is A plus Q minus 1 into D. And AR, this is equal to A plus R minus 1 into D. Now this is our, they are the terms of an AP. These are the terms of an AP, but these are AP, AQ, and AR. They are in GP. It is given to us. Therefore, A by Q by AP is equal to AR. AQ by AP, that is equal to AR by AQ. So value of AQ is A plus Q minus 1 into D, and AP is A plus P minus 1 into D. And this is A plus R minus 1 into D, and this is A plus Q minus 1 into D. Now, one thing I can do here, that is, one thing I can do, see, I have written this earlier. Now, what I am going to do, subtracting 1 from both sides, subtracting 1 from both sides, subtracting 1 from both sides, subtracting 1 from both sides. So when I subtract it from both sides, this will become this. Let me clear it here, here. That is A plus Q minus 1D by A plus P minus 1D minus 1 is equal to A plus R minus 1D by A plus Q minus 1D minus 1. Your LCM will become A plus P minus 1D, A plus Q minus 1D minus your A, this is A, minus P minus 1D. Here this is A plus Q minus 1D, A plus R minus 1D minus A minus Q minus 1D. This thing I have written here. This very thing I have written here. So now when we solve this, this AA cancels out. I am taking D common. So Q minus 1 minus P plus 1, this minus P plus 1. And here A cancels out, D common, R minus 1 minus Q, then minus Q plus 1. C minus 1 plus 1 cancels out, that is Q minus B. D and D cancels out, this and D and U can cancel out. So minus 1 plus 1 cancels out, Q minus P. Here minus 1 plus 1 cancels out, R minus Q. Now what I am going to do, just bring this here to the numerator and this to the denominator. And this is what? This is the common ratio. This is the common ratio. This is the common ratio, R. This is the common ratio. So your common ratio is equal to R minus Q by Q minus P. This we have to prove here. See, in the book, common ratio is this. So this is over.